So again, I have everything that is due on the board for the rest of the semester, which looks kind of cool because look, it's only this many lines long. So again, you're going to turn in section 6.6 today. We lectured on it both Monday and Tuesday. So we're going to start section 6.7 today. We'll do 6.8 tomorrow, and that wraps up all the lectures in terms of content. Those are both due on Saturday. You have quiz 8 due on Sunday. And don't forget, you have your last discussion. The initial post on the application problems for module 4 is due on Sunday also. Tuesday is the review for exam 4 and then exam 4 itself. Thursday is the review for the final exam and the final exam. Again, don't forget to be scheduling that exam 4, folks, because that 72 hours is going to come up on what, Saturday, right? Would be 72 hours again, Sunday, Monday, Tuesday. Yeah, so make sure you get that exam 4, start scheduling it in ProctorU. Okay, so let's move into section 6.7. I did send out the lecture notes, and it's mainly because they're all application problems. So section 6.7 is for the business world. All about compound interest. Okay, so, and again, it's a finance kind of thing. So compound interest basically means, well, there are 2 types of main interest. Simple interest, you just put your money in the account. It just sits there, does absolutely nothing, it literally just sits there. And at the end of time, they decide how much interest you've earned. And then when you take it out, they give you that interest and your initial principal, and that's it. That's simple interest. That's no fun. You might as well not even put it in the bank. Now, compound interest, what happens instead is the interest is actually added on periodically, so you're reinvesting more money to gain more interest on. So the interest is being compounded periodically, which adds it back in. So we have 2 basic formulas we need to talk about. The first one is the compound interest formula. Now, these are at the beginning of the handout if you were able to print it. And it basically says that A is equal to P times 1 plus R over N to the NT power. Well, that's great, but it looks like alphabet soup. So we need to go through and talk about what each of the variables are. So A is always the amount of money at the end of time. So that's how much money you've gained altogether. P is what's called the principal, and that's the amount at the beginning. So that's how much you're investing. So A is the end, P is the beginning. R is your interest rate, and it must be in decimal form. And for some reason, at this point in the course, this really throws people off. You know how to make a decimal into a percentage and a percentage into a decimal, so be careful with that. T is the time. It has to be in years. For the finance world, it must be in years. When we do the science applications of the exponential function tomorrow, time's not going to matter. It can be in months, days, years, seconds, centuries, doesn't matter. Finally, N. N is the compounding amount. What it really stands for is how many times it's compounded in a single year. So this is where the interest being tacked on comes into play. So in terms of N, you could have several different values for N. If you do yearly, then N is equal to 1. If you do bi-yearly or semi-annually, then N is equal to 2. So that would be 2 times a year. You could also do monthly. Oh, I'm sorry, let's do quarterly next. I'm trying to do them kind of in a numerical order. So quarterly. So in the business world, sometimes you do quarter reports. So N would be equal to 4. There are always 4 quarters in a whole. Then you would have monthly, and that would be N equal to 12. You could also do weekly. And there are 52 weeks in a year, so N would be equal to 52. And then finally, you can do daily, where N is equal to 365. So those are the different values for N. So yearly, semi-annually, quarterly, monthly, weekly, and daily. And those are pretty much the only ones you see. It's interesting to note that we will use 365 for daily, but the banking world actually uses 360. I think because it's a better number to work with, and because there are government holidays or banking holidays they're called. So, but we'll use 365. We don't worry about leap year. Okay, that's the compound interest formula. Again, we'll use it here in just a minute, but that way we've got everything defined for you. You do need to have the formula memorized. So you do need to know it in order to be able to take that exam. Then you also have something that's called continuous interest. Which simply means that the interest is being added on all the time. So not at the end of the day, not at the end of the quarter, not at the end of the year, but continuously. So continuous interest, which is the easy one to remember, is A equals PE to the RT, and that's our friend that we talked about last week, that 2.7183. That's E again. So A is still the amount at the beginning of time, P is still your principal, R is your interest rate, and T is your time in years. So those are the two formulas, and yes, you need to know them. No. Okay. So to help us out, I'm gonna erase what's due, because we've seen it, and then write the two formulas over here on the side to keep so that we've got them. So compound. Equals P times 1 plus R over N VNT, and then continuous, the easier one because it spells a word, PERT. And we'll come back and use this PERT formula again tomorrow. We're just going to change the alphabet soup, but it's still basically the same formula. Okay, so those are our formulas. Let's start using them. So example 1 asks us to find the amount that results after $600 is invested at 5% compounded daily for a period of 3 years. So you've got $600, you want to put it in an account, make some money off of it. So P, the principal, is that initial $600 that we're trying to invest. A is the amount that we don't know. So we want to know how much money we have at the end. It says find the amount. So A is the unknown. The interest rate R is 5%, which translates into 0.05 as a decimal. Compounded daily, that's our compounding amount. We know that daily means N is equal to 365. And finally, for a period of 3 years is T equal to 3. So I've taken all the numbers and assigned them a letter so we can plug them into our formula. So P is the 600, A is unknown, the interest rate is 0.05, N is 365, and the time is 3 years. So we'll pick up our compound interest formula. So A equals P times 1 plus R over N to the NT. And then we'll start plugging the numbers in. So P we're going to replace with the 600. 1 plus the interest rate we said was 0.05. And notice that as I bring it in, I'm going to keep writing it as that decimal. I will never use it as a percentage. N is 365. And then on the outside of the parenthesis, you're going to have that power, or the exponent is 365 times your time, which is 3. So the exponent sitting out there is 365 times 3. Okay, and the biggest issue here is just getting you guys to calculate it correctly. So I'm going to be waiting on you guys to give me my numerical answer. So if you don't have your calculator, go get it. Bring it back. So I need you to run that through your calculator and tell me what you get as an answer. When you go to type this in on that exponent, make sure you put parentheses around the exponent and also put parentheses around that inside division. And then you should be able to just type it in directly like that. So tell me what you get once you get it.
I don't think I got it right, but it's
not. Go ahead.
600.012.
No. So
Yeah.
you should get 697.
I got 697. Yeah.
09. Okay.
Yes.
So let's see, Adam, are you using a graphing calculator?
Yeah.
Okay. So literally, I don't think, so I typed it in without this set of parentheses in there.
Oh wait, hold on. Let me change something. I think I see where I messed up.
Okay. Good morning, Rich. We're just walking through the first example on the worksheet or the handout. And I'm just trying to make sure everybody's using their calculator correctly. So we're doing a compound interest problem.
Okay, yeah, I got it right.
You got it? Okay. Woohoo.
Yeah.
Yay. So, yeah, I wouldn't want to be doing these on the phone calculator because you got all these parentheses floating around and so forth, but good. So, no, notice you didn't gain much. You left your money in the account for 3 years, but you gained almost $100. You gained $97. So I guess that's not too bad. You just let it sit there and do nothing, right? So that's why they say if you're going to invest, invest big. But we still gain.
So I got a question. So like the 365 and then the 3, that's just that saying that it's daily. It's 365 days in a year and then it's 3 years, right?
Correct. That's exactly it. So you're gaining interest all 365 days for the 3 years, which is what that exponent is doing. So it's building that many times. So, okay, example 2 asks, we want to find the principal needed now to get $1,000 after 1 year at 12% compounded continuously. So I'm going to do the same thing again. I'm going to identify everything. This time, because it says continuous, I know to switch gears and use the PERT formula. And notice that comes directly from the sentence itself. That's what's telling me which formula to use. Okay, what do we know? Well, so those are the variables in our formula, A, P, R, and T. Find the principal needed now. So the principal is the unknown. We know we want $1,000 after 1 year at 12%. 12% translates into 0.12. So there's all the information. So now we'll plug that into our formula and then work on our formula. So 1,000 for the amount is going to be equal to P(e) to the 0.12 times 1. So as an exponent up there, I never know which looks better to you guys. I'm going to put a dot as a 1, but then people say, is that an exponent or is that a decimal? I don't know. But it's 0.12 times 1 up there as the exponent. Okay, well, we need to solve this for P. So P is going to be equal to the $1,000 divided by E raised to the 0.12, because 0.12 times 1 is just 0.12. Okay, take that to the calculator and tell me what principal I have to use now. Anybody?
Got
Go ahead, what'd you get?
886.
Yep, that is correct. And then because it's money, we're going to carry 2 decimals. So 0.92.
Yeah.
So this is saying if you put $886.92 into an account today, in 1 year, if you could find 12% interest, you'd have $1,000. So you've gained what, $114 a year? That's not bad at all. Of course, 12% interest is only for like credit cards and those kinds of things. So good. Anybody having any problems with the calculator? Because that's the biggest issue. It's not the algebra and it's not the arithmetic, it's the calculator. So we're good?
Yes.
Okay. So example 3 is asking us to compare interest rates. So this is showing you the effect of the interest rate and how often it's compounded. So example 3 says, which of the following 2 rates would yield the larger amount after 1 year? So 9% compounded quarterly, or 9.25%, oops, 9.25% compounded annually. So because I don't see the word continuous, I'm not going to use the PERT formula. We'll use our first formula. But they left off a lot of information. They did tell me that the time is 1 year. but they didn't give me a beginning amount to use. So we can use any amount we want. So we're going to invest some money. How much money would you like to invest? So what's a good number to use for our P? You literally can just choose.
10,000.
Yeah. Let's use $10,000. Sounds good. Let's backtrack and make sure we all recognize that in terms of an R, for the 9%, we'll use 0.09. And for the 9 1/4, what would that be as a decimal?
9.25.
Yep. So we're going to change that into 0.0925 when we change it into our decimal form. Correct. So 9 1/4 would be 9.25. Move the decimal 2 places. Nice. Good job. Quarterly means an N of 4, and annually means an N of 1. Okay, and I think that gives us all the information we need. Okay, so we're going to work this problem twice. So let's do the 9% first. That would be A equals our $10,000 times 1 plus the interest rate, 0.09, divided by 4. That's the quarterly. And we're doing this for only 1 year, so up there in the exponent is 4 times 1. Or just to 4. Okay, then have at it. I'm going to try and move the board a little closer to make that a little bit bigger. I don't know if that helped or not. Okay, and as soon as you get the answer, let me know what you got.
I got 10,955 and 18 cents.
Wow, that is not what I got. I got 10,930 and 83 cents. Huh, somebody else?
Yeah, I got the 930.83 as well.
Yeah, are you doing the other one maybe, Christina, on the 9 1/4%? Because now we have to go do the 9 1/4%. So that would be 0.0925. But this time it's only going to be divided by 1 because it was annually. And that would be 1 times 1 as an exponent. So on that one, I got 10,925. And even because it's for 1 year, so literally all the ones are kind of not necessary, right? So double check, make sure that we all agree. So what it's really asking is it better to have a lower rate but compound it more often? Or are you better off with a higher rate and compounding it less often? So we have 2 things going on here, right? We have a difference in the interest rates, but you also have a difference in the compounding. So for us, it was better to go with that lower interest rate and compound it more often. So for us, the 9% is the better choice in terms of money. So we gained an extra $5 over the course of the 1 year. So comments or questions about that? Is everybody getting the answers okay on their calculators? Yeah? Okay.
Yeah.
Okay, example 4. So example 4 asks, how many years will it take for an initial investment of $10,000 to grow to $25,000? Assume a rate of interest of 6% compounded continuously. So again, I'm just going to identify all the information, the alphabet soup as I call it. So our beginning amount is 10,000. It's always going to be the smaller amount of the 2. The end amount is 25,000. So we want to end up with $25,000. We are investing it at a rate of 6%, so that would be 0.06. And it's continuous, so I don't need an N because it's continuous. What we're looking for is the time. So for the first time, the variable is going to appear up there in the exponent. which is why this appears in this section. So, okay, I think I've identified everything. Let's come in and use our formula. So our formula is A equals PE to the RT because it says continuous. A is the 25,000. P is the 10,000. E to the 0.06, and then times T. So there's the variable sitting over there. And now we're right back to where we were yesterday in terms of solving an exponential equation. So it's why I like it. Okay, let's walk through what we got to do. In order to solve for this T as an exponent, the very first thing you've got to do is get rid of this 10,000. So our first step is going to be to divide both sides by the 10,000. And I'll just cancel off zeros. So that's 3 zeros canceled off. So now it's 25 divided by 10, which is what? 2.5 equals e to the 0.06t. Now, you will see that if it doesn't divide nicely, I tend to not divide it here. I would go on and carry it as a fraction until the very, very end. But this one divides fairly nicely. So 2.5 equals e to the 0.06t. Okay, now what do I do? How do I get this exponent of t out of the exponent spot?
Log of E.
Beautiful, thank you. And not only the log of each side, the log with what base? We're going to use log base E. So specifically, we're going to use the natural log of both sides. Thank you so much, Rich. Good job. Okay, now why am I using ln versus log base 10 or log base something else? Because over here on the right side, that lets me move the 0.06t out in front and have the natural log of E left over. Then I'll have the natural log of 2.5 equals that. And the natural log of E is 1. So that's going to disappear out of the calculation. So T is going to be equal to the natural log of 2.5 divided by 0.06. And that'll give us how long it takes for 10,000 to grow to 25,000, which is a lot of money. So I'm imagining it's going to take a while. Make sure you close your parentheses. So I got 15.3 years. So you're going to have to let that money sit there for a long time for it to grow from 10,000 to 25,000. Okay, double check, make sure you got the same calculation. Okay, yay! Nicely done. You did do some of these in the 101 class, the prereq course, but these are going to be a little bit uglier again than what you saw there. So be a little more aggressive, I guess is another word to use. Okay, number 5 tries to put some application into it or some word problem is to it. So it says that John will require $3,000 in 6 months to pay off a loan that has no prepayment privileges. No prepayment privileges. In other words, there's no advantage in paying it off now. I've got $3,000 now. How much of it should he save in an account paying 3% compounded monthly? So in the 6 months, he'll have exactly $3,000. In other words, he just got a stimulus check from the government, and he knows that in 6 months, he'll need $3,000 of it. So how much can he go spend now and still have enough to pay off the $3,000 in 6 months? So, and again, this was taken directly from the book. It's an awkward problem, but it's out of your textbook. Okay, so what they're asking us is we know that the amount that I need at the end of 6 months is the $3,000. I'm trying to figure out how much I need right now to invest so that at the end I have that $3,000 that I need. Let's see. Time here is goofy. It's 6 months. Well, that doesn't work. I need that in years, so that's going to be 0.5 years. What else do we have? Compounded monthly. So because I see the word compounded monthly, I know I need an N. Monthly means 12, and the interest rate is 3%.
Yeah.
Question? We're all good? Okay, so there's all the information we have. We're going to pick up our compound interest formula with the N in it and plug the numbers in. So 3,000 is equal to P times 1 plus 0.03 for my interest rate divided by 12 to the 12 times 0.5. So what I really want to do is I want to make all of this into some ugly decimal. Let's go figure out what all that stuff is as a decimal. So I have 1.015094063. So 1.015094063. That's just the stuff that's in the parentheses with its exponent. Is that what you guys get?
Yeah.
Anybody?
Yes.
Okay, woohoo. Now the problem is you don't round in the middle of these problems, because if you do, you'll get wrong answers. So I need to carry all of these decimals. I'm gonna let the calculator do the work. So what I'm gonna do is I'm gonna do on my calculator, because that decimal is still sitting there. I'm gonna do 3,000 and then divided by second, and then the answer ANS, which appears, if we haven't talked about it a lot, right above the negative key. So that way it carries all the decimals for me. And that's going to give me P. And I'm going to end up with 2955.39. So it's kind of a quirky problem if you ask me. And is that what you got?
That's what I got.
Okay, good. So what we're saying is that he's got 3,000 burning a hole in his pocket right now. If he puts $2,955.39 into an account, he then has what, $45 he can go spend on a meal or on whatever, and still have the 3,000 that he needs at the end of the 6 months. So not a lot of money to spend right now, but any bit helps. So what we're trying to do is make sure that you can solve for all the different variables that are floating around. So, okay, example 6. So example 6 says, Kelly has $10,000 to invest and wants to have a $25,000 in the account in 10 years for her daughter's college education fund. If the account pays interest continuously, what interest rate is required? Okay, so again, I see the word continuously, and that's telling me to use the PERT. So I need an A, I need a P, an R, and a T. So we have 10,000 to invest, so that's the initial amount of money. We know that we need 25,000 at the end of time, which is 10 years. And our interest rate is, oh, we don't know. That's the unknown. So we got to go figure out our interest rate. And I just think it helps to identify everything first, because there's a lot of numbers being thrown at you. And again, P is always going to be smaller than A, always. Okay, so our formula is PERT. A equals P E to the RT. A is the 25,000. That's equal to 10,000. E to the R times 10. And now we got to go solve for R. Very similar to the one we already did. So this time we're solving for R versus time. Okay, what's our first step? How am I going to solve for R? Anybody? So we talked about this yesterday. In order to solve for an exponent, you have to get the exponential term by itself. So that's saying I need to isolate the e raised to the power. So the very first thing we're going to do is come in and divide by 10,000. So that'll give me e to the 10r equals that 2.5 again. So like I said, it's really similar to the last one. So 2.5 equals e to the 10r. And then the only way we have of bringing the exponent down out of the exponent position is to take the log of both sides. Again, we'll use ln because we've got an e floating in there. So that's going to give me the natural log of 2.5 equals, on the other side, I'll have 10r, the natural log of e. I'm not sure I should be skipping steps, so I'm just going to write the natural log of e to the 10r. So again, on the right side, that lets you bring the 10r out in front times the natural log of e. And the advantage to that is that that natural log of e is equal to 1 and disappears. So r is going to be equal to the natural log of 2.5 divided by 10. And this will be a lot easier tomorrow because you would have done the homework or gotten that homework done where you did all of this. So natural log of 2.5. So when I did, I got 0.0916, which would be 9.16%, or I guess you could round it to 9.2%. Follow the directions on the homework on the rounding. Just depends on what they want. So, okay. Comments or questions about that one?
No, I'm good.
Yay! Okay, one more. Okay, so this is example 7. It's got multiple parts to it because we just want to see the effect of the compounding that's going on. So it says, how long will it take 5,000 to double if it's invested at 9.25% compounded? And then it's got several parts to it. So we want to double. We're starting off with $5,000. And the interest rate is 0.0925. Okay. And then part A is asking, whoops, dropped it, if we're compounded annually. So annually means n is equal to 1. Okay, well, if I'm doubling it, that means the amount at the end needs to be 10,000. So, okay, and we're going to walk through the same process multiple times here. So by the end of it, you should be kind of used to it. So because it's annually out, we're going to pick up the compound interest formula, which means that A equals P times 1 plus R over N to the N times T. So that would be 10,000 equals 5,000, 1 plus 0.0925 divided by 1 raised to the 1t as an exponent. And again, our job is going to be to solve for this t. So, okay, well now what? So this is similar to the one we just worked. The variable is sitting up there as an exponent. So we need to isolate the power, the base and the exponent term. So we're going to divide the 5,000 out. Well, if I divide both sides by 5,000, we're going to get 2. And that's the doubling that's going on. Now on the inside of this, 0.0925 divided by 1 is still 0.0925. So the inside of that parentheses we can do in our head comes out to be 1.0925 raised to the t power. And now all we have to do is solve for t. So to bring it down, we're going to do that same, taking the log of both sides. Because I don't have an e here, I don't have to use the ln. I could use log. It just depends on which one you feel more comfortable with. I'm going to use log just to remind you it doesn't matter really which one you use. So we're going to do log of 2 equals the log of 1.0925 to the t. And again, the advantage is that you can now bring the t out in front. So, sorry, don't put an equal sign there. So that's now t times the log of 1.0925 equals the log of 2. And because we're solving for t, all we have to do at the end is divide. So t is going to be equal to the log of 2 divided by the log of 1.0925. And that'll give us our answer. So 2, and I'm going to wait on you guys this time. I'm not going to give it to you. I have to admit that's where I've been challenged this summer, is waiting on you guys to respond. I need to do a better job of that in the fall. Okay. Anybody?
Is it 7.83?
Because we're in money, that's going to be in years. And I actually want to keep track of these. So for part A, when n was equal to 1, it ended up being 7.83 years. Okay. So now we're going to do the same thing again, but we're going to change the compounding period. So for part B, we're going to come in and do semi-annually. So that means n equals 2. And this does make the decimal part of this a lot uglier, but it works well. So we'll start off the same way. We know we have 10,000 at the end. We started with 5,000, and we have 1 plus 0.0925 now over 2 to the 2t. Okay, now because I tend to not use my calculator until the very, very end, it ends up having to write more, but at least I don't lose any decimals with this thing. The first step's still going to be to divide the 5,000 out. We already know when we divide it out, we get 2. So 2 equals 1 plus the 0.0925 divided by 2 to the 2t. So you have your choice here on how you want to do this. I'm going to carry this and take it to the calculator at the very, very end. You can figure out what this is as a decimal, but then you have to write all the decimals down. So it's up to you. I tend to not do that until the end. We're going to come in and take the log of both sides. Let's use ln this time. I want them both in your notes so you can see you can either one. So ln of 2 is equal to, I'm going to write the 2t out in front because I already know it's going to bring it out in front, times the natural log of everything in the parentheses. Then to solve for t, we're going to take the natural log of 2 and divide by everything but the t that's on the right-hand side. So that would be a 2 natural log of 1 plus 0.0925 divided by 2. Okay, and now I go to my calculator. You might want to make sure you put the entire denominator in a set of parentheses. 2 divided by okay. So we already know it should be the ballpark of 7 years somehow. Anybody? You guys are really quiet on me. I got 7.67, 7.665, so 7.67. Is that what you guys got? Somebody?
Yes.
Anybody?
Yes.
Okay, thank you. Phew. Okay, so now what we're going to notice is that we're doing the same process on all of these problems, for problem number 7. So what I'm going to do before I do parts C and D is I'm actually going to take the formula and solve it for time so that I don't have to keep doing all this writing. So if I just come up with my own formula, which is the advantage of doing the algebra, then I don't have to keep writing it every single time. So before we do part C, we're going to come in and simply start off with that compound interest formula and solve for T. And we can kind of see it's the same process we've been doing. It just has got the letters in it versus the numbers in it. So the very first thing we have to do is divide out the P. So that's going to give me A over P equals 1 plus R over N to the NT. So that's where the 2 is coming from in our work. Okay, now because we're solving for T, we need to take the log of both sides. I'll use ln only because it's quicker to write. That is literally the only reason I use it. I can make an ln a lot quicker than I can do an log. So on the left side, you're going to have the natural log of 1 plus r over n. I'm sorry, on the right side to the nt. And we know that we can bring the n times the t out in front and multiply it by the natural log of the inside stuff. Okay, and because we're solving for t, we're going to divide both sides by everything else. So t is going to be equal to the natural log of a divided by p all over n times the natural log of the inside stuff. So now we have a formula we can use. So instead of having to rearrange every single time, we can just plug into that formula. And the only thing that's going to be changing is our n. That is it. That's the only stuff that's changing. So, okay, and I need my formula somewhere. So I guess I'm going to reset the top, write it down. So t equals the natural log of a divided by p all over n times the natural log of 1 plus r over n. Okay. So hopefully everybody can see why we would need to do that. So now we can do part C and see if it's any quicker to do it, now that we've solved our formula. So part C says, now what we're going to do is do it monthly. So that means that n is now equal to 12. So using our newly developed formula, I'm going to go ahead. I already know that a divided by p is 2, so I'm just going to write in the 2. It just saves us a little bit of time. That's that doubling that's going on. All over 12 times the natural log of 1 plus 0.0925 now divided by 12. So we saved some time on having to solve it. And again, make sure you put the entire denominator into a set of parentheses, otherwise it'll divide by just 12 and not the whole thing. So. Dropped a 1 on my 12.
8.43.
What'd you get?
8.43.
I got 7.52. Somebody else is agreeing with that? And I, no offense to your answer, but I'm liking my answer because you'll notice they're all pretty much very similar in terms of 7 years. It's just on what month it's doubling in. And according to my notes, it should be 7.52. Double check to make sure you've got the right number of decimals in that 0.0925 and that you've got 12 in both places. When I first typed it in, I dropped one of these ones and just put it 2, and I got 45 years. So just one missed number makes a big difference. Okay, part D on that problem says, now let's come in and do daily. So if you reinvest that money daily, what happens? And we know that daily means 365. So t is going to be equal to the natural log of 2 again, all over 365 times the natural log of the 1 plus 0.0925 over 365. That's really sloppy. Okay. Natural log of 2 divided by 365. Natural log. That's 0.0925. Okay, and I got 7.494. So. Okay, so we can see that investing it or compounding it more often is increasing, or I'm sorry, decreasing the amount of time it takes to double, but we're only talking months over here. And part of that is because the interest rate is so huge. We saw a larger interest rate, we would see more of a difference over there. So, okay, did we get that one okay? We got one more part.
Yeah, got that one.
Okay. Then finally, part E, part E, not part E, says continuously. So now we have to skip formulas. So the minute it says continuously, we know to go use our PERT formula. So the formula we just developed is no good. We're going to go back to PERT. So 10,000 equals 5,000 E, the 0.0925 times T. And we've done this multiple times now, so it should feel a little bit better. We know we divide out the 5,000 first. That's going to give us 2 e to the 0.0925 t. Then we'll take the natural log of both sides. Again, specifically, we've got an e, we'll use natural log. So the natural log of 2 equals 0.0925 t, natural log of e. And notice I just bring the exponent out in front automatically. The natural log of e is 1, so that disappears on us. So t is going to be equal to the natural log of 2 divided by 0.0925. So 2 divided by 0.0925. And I get 7.493. This was 7.494. And for continuous, I get 7.493. So not a big difference between daily and continuously in terms of the years. You're talking like maybe a half a day, right? In terms of 12 months in a year. So not a big difference, but it does make a little bit of a difference. And again, part of it's how much money you're investing and what the interest rate is. But okay, and that's all of the business finance ones that you're going to be doing on the homework that's due on Saturday. Okay, anybody have any question about it?
Okay.
Okay. It's a little more interesting tomorrow because tomorrow we'll come back and do the science formulas. So we'll talk about exponential growth in populations and exponential decay. So everybody good?
Mhm.
Yeah.
Fantastic. Have a fantastic day. Enjoy it. Don't forget you got section 6.6 due tonight, okay?
Okay,
Bye-bye.
Okay, thank you.
bye.